Hey, Algebra 2 Trig, we're finishing up 10.6, special polar graphs. The essential question is, how do I graph special polar graphs? And then before we start, I'm going to give you a bunch of graphs that you do need to write down. Okay? And also write down all the other stuff too. I will tell you what to write down. So, for instance, okay, these are all limicons. And then you need to write down this formula, and I'll tell you the conditions for each one of these graphs will show up. Okay? And then I'll explain it very quickly. A is the number in front. Then B is the number next to either the sine or the cosine. And then depending on what the ratio is, if A over B is less than 1, then it's going to look like a limicon with an inner loop. If A over B is equal to 1, it'll be a cardioid, which kind of looks like a heart. And then if A over B is between 1 and 2, it's going to look like a dimpled limicon. And then if A over B is greater than or equal to 2, it will be a convex limicon. Okay? Next we have graphs that look like this. They're all rose curves. And then depending on, so it depends on what A is and what N is. So I'll tell you when N is odd, it will have N petals. And it'll have 2 N petals if N is even. And again, it'll kind of look like these. We'll go over a problem like this so you know. Okay, and then last one, we have circles and lemniscates. Okay, and then if you notice, all circles have cosine theta. There's no number in front of the theta, and that's what makes it a circle. And then the lemniscate, it's probably the most obvious one. It's r squared. We don't deal too much with these, but you will try to graph them. Okay. All right, so let's try to graph a couple of them so I can show you how it works. Kind of go through the steps. Okay, so I'm going to graph r equals 3 sine 2 theta. Okay, so the first thing I want to do is I want to identify what kind of graph it is. So if I remember from my special polar graphs, okay, it will be a rose curve. Okay, and then if you look at n, n is the number in front of theta, so it's right here, and it tells me if n is even, it will have 2 n petals. So therefore, since n is 2, it will have 4 petals. I know it will have 4 petals. Okay? And then after that, I can go ahead and graph. Okay? So the next thing I want to do is I want to find where r is 0. So I'm going to find where r equals 0. Okay? So r equals 0 when, so I'm going to set r to 0, so r 0 equals 3 sine 2 theta. Okay, I'm going to divide both sides by 3. And then 0 equals sine 2 theta. Okay, so where is sine 0? Sine is 0. So 2 theta will equal, sine will be 0 at 0 pi and 2 pi. And then after that I have to divide by 2. So theta is going to be at 0, pi over 2, and pi. Okay? Alright, so let's go ahead and make our chart and go from there. Okay, so I'll have theta and I'll have r. I'll try to list as many as I can and then start going from there. Okay, so if let's just start with when theta is 0. So when it's 0, I'm going to plug into the original equation. Well, at 0, I already know my r is going to be 0. Okay? And then I'm probably going to just pick some random ones in between. So if I go ahead and pick pi over 2, actually let's pick pi over 4. And the reason why I want to pick pi over 4 is because if I plug in pi over 4 here, it will be, I'll write it up here, it will be r equals 3 sine of 2 times pi over 4. Okay? 2 times pi over 4 is pi over 2. And if you notice, sine is 1 at pi over 2, so my r is going to be 3. Okay, so I probably want to try all the ones with the 4 as a denominator, because I'll give you my biggest value, because sine's biggest value is 1 or negative, and the lowest value is negative. Okay? Alright, and I'm going to do pi over 2. So if I pick pi over 2, I know that was one of my thetas where r was 0, so now it's 0 again. And then let's pick one between pi over 2 and pi. That would be 3 pi over 4. Okay, so if I plug in 3 pi over 4 in here, it will be 3 times sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 1 times 3 is negative 3. Okay, and then at pi, it's going to be at 0 because that was one of the thetas I found. Okay, and then let's keep going. Let's go 5 pi over 4. So 5 pi over 4 is 5 pi. It'll be, in other words, r equals 3 sine of 5 pi over 2. 5 pi over 2 is 2.5, so it'll be 1, so this will be 3 again. And let's just keep going. 3 pi over 2. 3 pi over 2 will give me 0. And then 7 pi over 4 will give me negative 3. Actually, it will give me 7 pi over 4 will be 7 pi over 2. 7 pi over 2 is 3.5 pi's. So it'll be negative 3. And then last one, 2 pi. 2 pi will give me 0. Okay, so now I have where r is zeros. I know it's a bunch of 3's and negative 3, so let's roughly graph it. Okay, so at 0 it would be 0. At pi over 4 it's 3, so pi over 4 is pointing in the 45-degree region, so it'll be somewhere out here. Okay, and then at pi over 2 I'm back at 0, so at pi over 4 I'm going to 3, and then at pi over 2 I'm at 0, so that'll be one of my petals. Okay, at 3 pi over 4, which is at 135 degrees, it's at negative 3, so it's actually pointing this way, so it'll be a negative 3 here. And then at pi, go back to 0. Okay, at 5 pi over 4, 5 pi over 4 is here, it'll be at 3, so I'm here, finish the petal. And then at 3 pi over 2, it's back at 0. See how important 0 is? And the last one, 7 pi over 4. So 7 pi over 4 is here, it's actually pointing at, it's pointing this way in the 4th quadrant, but it's negative, so it's going to go the other way, so somewhere here. And then I'm going to graph that and close off the petal. Okay, so there's my rose curve with 4 petals. Okay, so let's do another example. Let's do number 2. Let's graph. R equals 1 minus 2 cosine theta. Okay, so again, first thing I want to recognize is what special polar curve it is. So if I recognize it's a sort of limicon. It's a limicon. Okay, A over B, this is A. This is B. I'm going to ignore the negative. It's not really that important until I start graphing it. So A over B is 1/2. A over B is 1/2. Okay, if A over B is 1/2, that means it's less than 1, so therefore it's going to have a limicon with an inner loop. Okay, the next thing I want to do, I want to set r equals 0, so let's set r equals 0. 0 equals 1 minus 2 cosine theta. I'm going to add 2 cosine theta to both sides. So 2 cosine theta equals 1. Cosine theta equals 1/2. Okay, so then I want to know where cosine theta is 1/2. So my theta will equal, so where's cosine 1/2? It's going to be at pi over 3 and 5 pi over 3. Okay, so that's where my r is going to be 0. I'm going to make a table, theta and r. Okay, so my table is going to start with 0. Usually start with 0 radians. So if I plug in 0 into this equation right here, cosine 0 is 1, 1 times negative 2 is 2, so this will be negative 1. Plug in pi over 3, plug in pi over 2, plug in 2 pi over 3, and then plug in pi, and then let's plug in 4 pi over 3, and do 3 pi over 2, and then 5 pi over 3, and then 2 pi. Okay, so let's do all those. In fact, why don't you pause the video and try to figure out all the values right now before I start. But I know at pi over 3 and 5 pi over 3 is going to be 0. Okay, and then at pi over 2 it would be 1. At 2 pi over 3 it would be 3. Okay, at pi, at 2 pi over 3 would be 2. At pi it would be 3. At 4 pi over 3 it would be 2. At 3 pi over 2 it would be 1. And then at 2 pi it would be negative 1. Okay, so hopefully you got those right. And then let's go ahead and graph it. Again, knowing that it's a limicon with the inner loop will make my life easier. So 0, negative 1. 0, negative 1 is right here. Okay? And then pi over 3, 0 is right here. So how do I get from here to here? This looks like probably my inner loop. Well, let me make sure. At pi over 2, it's 1. So pi over 2, it's 1. So I'm here. So how do I get from here to here? It's probably going to be my inner loop. I'm going to go like this. Go to pi over 2, 1. Then I'm going to go 2 pi over 3, 2. So 2 pi over 3 is roughly here. So it's going to be 2. So right here. And then I'm going to go to pi 3. So 1, 2, 3. So again, I'm going from 0, negative 1 to pi over 3, 0 to pi over 2, 1 to 2 pi over 3, 2. Well, it should probably be smoother. Okay. And then to pi 3, which is here. And then to 4 pi over 3, 2. So 4 pi over 3, 2 is right here, roughly. And then to 3 pi over 2, 1, which is here. Okay. And then so I'm at 3 pi over 2, 1. Then 5 pi over 3, 0. I'm back to 0. And then 2 pi negative 1, which is right here, which is here. So I'm going to finish off the limicon. Kind of ugly, but this is my limicon. There's my inner loop. Okay, if you have any questions, go ahead and write it down, and we will talk about it tomorrow.